So this video is going to continue Chapter 9. It's going to cover 9.7 and 9.8. By the end of this video, you should know how to calculate surface area. So surface area is the area of all faces or surfaces that enclose a solid. So basically, like for example, if you have a cube, it's going to be not only the area of one face, but all of them. So bases are going to be your top and bottom. So this is kind of irrelevant for a cube. You can really choose whatever, but for our purposes, this is going to be your top, this is going to be your bottom. It matters in things like a cylinder. Your bases are going to be your top and bottom. Then the lateral faces, or surface, is going to be the remainder, everything else. So in a cube, these four sides, and in a cylinder, this all the way around. You can think of surface area as adding together the areas of each side of a solid, and sometimes it helps to draw out the figure as a net rather than a solid. So for example, for a cube, you could draw it out like this. And then that helps you visualize all the areas you're adding together. So if we have a cube and we say that the side is going to be 3 centimeters, what I like to do is I like to draw out the net of my figure and then put some measurements on it to really visualize what I'm doing. So 3 times 3, and then this is just repeated 1, 2, 3, 4, 5, 6 times. So what we can essentially do, especially for a cube because everything's the same, is find the area of one side, which is going to be area equals base times height, which we have base times height. So that's going to be 3 times 3 equals 9 centimeters squared. And then since we have 6 sides of equal size, we can just multiply this by 6 and get our final answer, which is going to be 54 centimeters squared. So if we're given a triangular prism, and as we can see this is going to be a right triangle here at the top, and we're given some measurements, so say this is 8 meters, this is 6 meters, and this is going to be 10 meters. So now we can draw the net of our figure. So we can start by drawing the lateral faces, and then we can draw our triangle on each side here, and then we can start filling in the measurements. So we know that this is 10, and then we're going to have to do a little Pythagorean theorem to find this side right here. So essentially what you're going to do, the Pythagorean theorem, is c squared equals a squared plus b squared. So we have a and b here, so 8 squared plus 6 squared equals c squared. So that's going to be 100 equals c squared, and so c is going to be 10 meters. So we have another 10 meters here. So then let's say that that's this side. And then we can say that then this is 6 and this is 8, so these are going to match here. And then we can begin to find the areas. We know that the area of the triangle is going to be the base times the height. So here and here, that area is going to be 8 times 6 over 2. But since we have 2 of them, essentially we can cancel out that 2 and get the area of our 2 triangles equals 48 meters squared. And then we can find the area of each of our sides, which is going to be 8 times 10, 6 times 10, and 10 times 10. And if we add those all up, we get 80 plus 60 plus 100, which is going to add up to 240. I'm going to go over here, put this 240, and then plus our 48 from our triangles. We're going to get a total of 288 meters squared. So to calculate the surface area of a square-based pyramid like this one, we need something new called slant height. So slant height is the height of each triangular lateral face of a pyramid. So it's going to be this value right here. And for this one, we're going to say that that is 8 centimeters. And we're going to say that the base of our square is 12 centimeters by 12 centimeters. And here this is 10 centimeters, but that's really not an important value that we need to worry about. So we're going to have one base and then 4 identical triangles. So that makes it pretty easy. We can find the area of the base plus 4 times the area of the triangles. So essentially the area of the base we know is going to be base times height, or 12 times 12, and then the area of the triangle is going to be base times height over 2, or 12 times 8 over 2. And these values are going to come out to be 144 here, and this is going to be 48 here. And we can add those up, and that is going to turn out to be 192 centimeters squared. So for a cylinder, we're going to need the length of the radius. For this one, it's going to be 5. And the height of the base, for this one, it's going to be 12. We're going to do inches. So here we just have a long lateral face, and then we have 2 circular bases. So we can find the lateral base. So this length is actually going to be the circumference of the circle, and as we know, circumference is pi d, or also 2 pi r. So we can find that by saying 2 pi and then inserting our radius r. So that's 10 pi. And then to find the area of our lateral face, that's going to be 12 times 10 pi, or 120 pi. And then the area of our 2 circular bases, so of one, it's going to be pi r squared. So we insert our radius value, that's 5 squared, or 25 pi. And if we have 2 of those, it's going to be 50 pi. So our total surface area is going to be 170 pi inches squared. And if you really want to multiply that out, that is going to be 534.07 inches squared. So for cones, we actually have a special formula. A equals pi RL plus pi r squared. So L is going to be the slant length. And in this one, that's going to be 10 centimeters, and we're going to have a radius of 5 centimeters. So we can plug that in, and that's going to be pi times 5 times 10 plus pi 5 squared, and that's going to equal 75 pi, or 235.6 centimeters squared. Then we have a new term. Frustrums are cones with their tops cut off. So if you ever encounter that, it looks something like that. Essentially, yeah, just a cone with its top cut off. How you'd have to find the surface area of that is essentially, if you were given the values, you'd find the total surface area of a big cone and then minus the smaller cone.